Hi, today we're going to talk about inverse functions. So, inverse functions are functions that quote unquote undo each other, meaning that if a function maps x to y, then the inverse function is going to map y back to x. In order for a function to have an inverse, it must be 1 to 1. In other words, this means that for each value of y, there can only be one value of x. In other words, the y values cannot repeat. To determine if a function is 1 to 1, we perform the horizontal line test. So the horizontal line test states that if a horizontal line crosses a graph more than once, then the function is not 1 to 1. Please do not get this confused with the vertical line test. The vertical line test is what we use to determine if a relation is indeed a function or not. And the vertical line test states that if you draw a vertical line, it should only touch the graph once. Otherwise, it is not a function. So please do not confuse the horizontal line test with the vertical line test. So inverse functions are denoted as f, and the -1 as the exponent is actually what we write as an inverse. Remember, a negative exponent means we're going to flip or invert something. And we pronounce this as f inverse of x, or you can say the inverse of f of x. So let's look at example 1. So example 1 says, consider the graph y is equal to f of x shown. Explain why f of x is an invertible function. So remember, the horizontal line test, we have to test it and see if it's 1 to 1. If the function is 1 to 1, that means that it does have an inverse. So as you can see, I'm drawing my horizontal lines, and these horizontal lines only cut through the graph once. So yes, this is invertible, and that is due to us passing the horizontal line test. So now for part B, it says to sketch the graph of the inverse function. So remember, the inverse function is going to swap the x and the y value. So if we look at our graph of y is equal to f of x, the 2 points that are there is -4, 4, which is here, and we have 3, -1. So for our inverse, or y is equal to the inverse of f of x, we swap the x and the y value. So we're going to have 4, -4, and -1, 3. And we can plot those. So if I plot 4, -4, I will be here. 1, 2, 3, 4. Go down 1, 2, 3, 4. I will be here. If I were to graph -1, 3, I will end up being here. And then I can draw the line between them. So that is my inverse in blue. So next, we want to state the domain and the range of f of x. And then we want to do the same for the inverse. So for y is equal to f of x, the domain will be in between -4 and 3. The range will be between -1 and 4. And remember, those are closed circles, so we include them or include those endpoints. So for the inverse of f of x, our domain is going from -1 to 4, and our range is going from -4 to 3. So basically your domain and ranges All they do is just swap from the original to the inverse. All right. So let's look at example number 2. So we're going to talk about how to find the inverse function from an equation. So the steps that you take are, number 1, you are going to swap the x and the y variables. And then you're going to solve that equation that you swapped for y. And then you will just rewrite y as the inverse of f of x. All right. So we already know that f of x by itself is the same thing as having y is equal to negative 2x plus 3 here. So if we swap, we are going to literally interchange the x and the y here. So when I do that, I will end up with x is equal to negative 2y plus 3. So now that I have this, I'm going to solve that equation for y. So I'm going to subtract 3 on both sides. And I end up getting x minus 3 is equal to negative 2y. And then I'm going to divide both sides by negative 2. So I am going to end up having negative 1/2 x plus 3 over 2 is equal to y. And of course, last step, we would change y into the inverse of f of x is equal to negative 1/2 times x plus 3 over 2. So that will be my inverse. If you have any questions, please save them for me so that I can address them when I see you the next time. Have a great day.